I think so. We start previous. So, good morning. I am here to talk about the role of AI in increasing the access to renal transplantation. As a disclaimer, first of all, I will like to admit that my 9th grader daughters are better than me in AI, and I hardly use AI in my real life. So, it was a learning experience for me as well. If we look at the transplant landscape in India, last year, we did remarkably well. We did around 19,000 transplants, which was a record, of which 12,000 were kidneys, obviously. But still, we were less than a million in providing access to renal transplantation. So, there obviously is a huge gap between demand and supply. There is huge inequality between the organ distribution, and we are still struggling with poor growth survival in our renal transplant patients. So, what we require is an equitable access and improve outcomes to improve the renal transplantation. Since I am talking about AI in improving access to transplantation, in my opinion, what are the major barriers for renal transplantation? Number one, obviously, is a late referral and delayed diagnosis. This is true for all diseases, whether we are talking about kidney failure, whether we are talking about liver or cardiac failure. We have challenges in identifying donors, both living as well as deceased, and they need to be referred to the for the declaration for brain death. The organ allocation is still suboptimal. So many organs are lost because either they are not processed properly or they are not transported to where they are required. And we have still very high cost of follow up subsequently, which makes people non compliant and non adherent to therapy, leading on to graft losses. So, if these are the barriers for transplantation, how will AI help in addressing these barriers? So, what I would be talking about in next 10 or 12 minutes would be, for ignorants like me, just explaining what AI is, how AI has remarkably changed our daily life and even our specialty of nephrology, and then how AI can actually improve the access to transplant, and what would be the challenges and future directions for use of AI. Well, in simple terms, artificial intelligence would refer to computer systems that can mimic human intelligence by processing large volumes of data, identifying patterns, and making decisions and predictions. It would usually excel in rapid multi-factor analysis that is well beyond convention means of our understanding or human understanding and normal computing. So the artificial intelligence would have multiple layers, would have multiple steps. The first to understand is machine learning, which actually is an algorithmic based statistical data in which that particular model is trained to give us particular outcome. Deep learning becomes a bit more complex. It would have multiple neural networks, similar, almost akin to our brain, and then they can be trained to do subsequent challenges. The final part would be to have generative AI, which would give us outputs in multimodal presentations, and that can be the final outcome of a good artificial intelligence. So, I did talk about the artificial neural network, which actually is brain for deep learning, and most of the AI practices which we have right now. You provide the system with a labeled data, and then it would go through multiple neural networks to give you a outcome. At any time, if you find that the outcome is not to the position where you would have expected it to be, you can actually tell the system that, and it can go back to square one and recompute and recalculate the algorithm to give you the desired result. So, from a simple no computation, we can actually make multiple complex layers to give a final desired outcome. This is how a AI system is typically trained. The initial part would be a supervised learning where you would give an input which is labeled, have a desired outcome, then train it on an unsupervised learning, which would give you some generalization. And then you can reinforce the learning, and then by giving it multiple real time tasks, and then it can retrain and train itself to give you desired results. How much complex or complicated the AI might sound, since morning we all would have used AI in multiple ways. Over the week we would have used AI probably more than what we would have talked to our wives. So AI practically is now into the length and breadth of our daily life. And though it might sound a bit complex, but the outcome, the interface is very seamless and very easy to use. In nephrology also we have multiple ways in which AI has made a huge dent, especially in predicting acute kidney injury, in predicting the patient who are at risk for acute kidney injury. In imaging, especially in detection of renal cell carcinoma, it's supposed to do better than a partially trained or non-expert radiologist who don't usually see RCCs. Various methods have developed which can predict the outcome of a kidney transplant. We would be talking about a bit later as well. For talking about the progression of chronic kidney disease, in kidney pathology, it again has revolutionized by remote access to renal slides and doing renal reporting. And in dialysis, obviously talking about the outcomes and improving the dialysis adequacy. So, with all these concepts of AI, how can AI make a dent in transplant access? Well, coming back to the barriers, which I thought are, in my opinion, the basic barriers for a wider access to renal transplant. So, we talk about role of AI in early patient referral. As I said, we have now good computation models which can tell us the rate of progression of chronic kidney disease. So, if we can identify those patients who are likely to progress faster, or identify those patients who would be requiring transplant in near future, they can be referred much more faster to a nephrology and a transplant team, and the issue of a late referral hindering a transplant can be stopped. So, as I said, we have multiple equations now, multiple AI algorithms now, which can detect CKD progression both for diabetic and a non diabetic CKD. The other way in which AI can help in organ allocation for the donor part is prioritizing the listing of the donor. So we can feed in the algorithm the clinical scenario, the lab reports of the patient, the radiological data, and then in a more unbiased way, AI can prioritize the listing of that particular person for a renal transplantation, therefore balancing the wait listing mortality with the post transplant survival. So this again would be a very important aspect in improving the access to transplant. AI can also increase the donor pool. This is a very interesting study done in 3 Texas hospitals in which they took out the ICU physician from the identifying brain dead donors. They left that task to the AI. So automatically the AI would alert the transplant team or the transplant coordinating team regarding the availability of a donor. And in 6 months, what they found was there were 45% more referrals to the organ transplant team. There were 83% more approaches, there were 73% more authorizations, and 92% more organ donation. So, just by giving a predefined clinical triggers which would identify a potential brain dead donor, the renal donation or the organ donation can increase dramatically if we leave it onto AI. The other aspect of disease donor organ donation is the wastage of organ. At times, the high KDPI organs are not accepted, they are refused. What AI can help us is AI can help us in balancing the need or utilization of a KDPI, high KDPI, say even more than 90 organ, for a matched recipient. So, if we know that this patient is unlikely to survive without a transplant, we can still offer him a high KDPI organ, very well understanding that this might not do that well as a good KDPI organ, but still it would be better than putting this patient on a life support. So, here in this algorithm also, AI can play a huge role. So AI can increase the recipient pool, AI can increase the donor pool, and AI can increase the organ utilization. The other aspect as I talked about was poor organ survival. And we all understand that the organ survival does depend to a certain extent upon the organ matching. And this is where AI can actually excel. AI can not only match disease donors from a multiple databases much faster, but it can also do it much better than a normal algorithm. It can also predict the organ utilization risk. For a live donor, a simple algorithm can tell you whether assessing or taking this live donor as an organ donor would lead on to any untoward effect to the donor or not. It can also balance the outcomes with the time to and distance of the organ utilization. You might have a very good match here, but the recipient might be far off. So you can still have the next best match donor which is nearby to do it. So obviously, this way it can help reduce the inequalities and make the organ donation more accessible to poorer and patients who are living far off. So, in addition, AI, as I said, can multiple not only talk about HLA, we can have multiple things uh, using heterogeneous data sets, which would include genetics, the medical history, the compatibility factors, to give you a highly personalized and precise matches. So, AI in donor recipient matching can predict likelihood of a successful outcome for different donor recipient combinations, especially if they are trained on a large database like UNOS. It can process data in real time, accelerating the matching process and ensure time sensitive organs are used efficiently. And it can reduce regional and socioeconomic disparities. Another way in which AI can work very well in a donor recipient pairing is in for swap transplantations. And we already have several real world tools available in AI to predict it. We have an organ predict tool, which is from the NHA, we have a kidney chain, and even UNOS registry now is actively taking up AI for matching the donors and the recipients. Another barrier which I talked about was poor patient compliance because of cost and poor adherence to therapy, which could be because of the huge distances the patient has to travel to meet his transplant physician. AI, by doing a better matching, can actually lower the upfront cost of transplant. It can do a more personalized matching, as we have already discussed, and therefore reduce the need for induction as well as desensitization. It can also lower the cost of hospitalization by using less immunosuppression. It can also optimize the hospital resources. So it can actually, certain hospitals now have AI to fix up the time, that this is the time required for the kidney or the graft to come or the liver to come. And they can free up their OT time accordingly and therefore decrease the cost of transplantation. And in fact, pathology and radiology, as I said, are two important tools in which AI has done remarkably well. And it can be used for remote sharing and proper utilization of resources, again bringing down on the cost. So we can have a AI protocol, we can have a whole module which can look at the remote vitals as well as the adherence alerts. It can predict the risk of infection and rejection. We can use it to optimize immunosuppression and therefore reduce the hospital visits, and therefore limiting the cost as well as the patient's journey to the hospital. So, this cartoon here basically tells us various ways in which AI can help in transplantation. I have not touched upon the robotics aspect, which is a surgical aspect in which again AI has done remarkably well. Now, if it's so good, what are the why it's not being taken up so well? There are subsequent challenges for a wider spread of AI, first of all, especially in a country like ours, we need to develop data sets with a good data quality. We have large data still being captured by individual centers, individual registries, state registries, which can be shared to have a more robust and a holistic data set on which a AI module can be trained. There can be subsequent ethical issues, and that can be actually met by focusing on explainability and transparency of the module which we make up for AI. There can be a black box phenomena, and to avoid a black box phenomena, we have to be more transparent in our algorithm development, and we should train practitioners how to interpret the machine learning outcomes, because a machine does it for you, you would always feel that it is rigged. So we are still having all the challenges about the EVMs and going back to the ballot papers. So it's just like being that you are never happy with what machine tells you, and you can always have a heartburn because of that. So it's by being transparent and by training practitioners to understand how an AI works, that part can be solved. Obviously, even AI is subject to biases. If you have all Caucasians in a population, the AI would be trained to only look at Caucasians. The blacks, the Hispanics won't be included. Similarly, if you have a database in India which is looking at only a particular state or a particular region, you can have that bias. So, for that, we have to have continuous auditing, we have to have a more inclusive data set, and we have to have a more transparent development and repeated external reviews so that the faith and the confidence in AI is always maintained. The biggest problem with AI is obviously legal validity. Who would be responsible if something goes wrong? And for that, we have to have, just like AI, good algorithms in place, and we should have a legal framework and regulation which would take care of that. It's not that India has not taken up AI in a big way. Niti Aayog actually, way back, more than 7 years back, took up Trinetra and digital pathology programs to have more widespread use of AI along with imaging. And we can just actually piggy bank along with this already initiatives of Niti Aayog which are going on to make a big data sets for renal transplant patients. One concern obviously is AI taking a job. I don't know how seriously it would affect the job for all of us. But one thing I can vouch for, it has taken up my job as a father. 3 years back, my daughters used to get holiday homework in which they had to write some proses, make some stories. And suddenly at the time of summer vacation, I was in great demand. Papa ye kar do, Papa wo kar do. For past 2 years, I realized they are not coming to me. So one day I asked them what has happened. They said, "No, ChatGPT does it all for us. Why do we need to come to you?" So this problem, I believe, is likely to come up subsequently as well, and that challenge we need to address. So, ladies and gentlemen, just to end my talk here, I believe AI can definitely improve the access to renal transplantation. It can also make it more affordable, have fewer complications. We need to adapt it more for the lower middle income countries like ours. The advantage is most of our country is already mobile first country. All of us have mobile phones, good, simple internet accesses. AI enabler of increased access to transplant, if used wisely, obviously, as I said, there are still challenges which we need to do. For us, AI still looks very complicated, still looks difficult, but in truth, we all have been using AIs in multiple ways. And AI, rather than artificial intelligence, if used with human brain, would be augmented intelligence, which probably would be the best for our science. Thank you.